Welcome to my class this morning, and I'll be discussing extraction of aluminium. As you all know, aluminium is one of the metals in the activity series. Aluminium is highly reactive, but this time around we're talking about how to extract aluminium. And so we'll begin with the ores of aluminium, and ore is a reservoir where a particular metal can be obtained in large profitable quantity, and ore is a mineral deposit where an element, a metal, can be obtained from it in large profitable quantities. So aluminium ore, we have major aluminium ore, and aluminium, being a highly reactive metal, belongs to group 3A of the periodic table. What do I mean by group 3A? We have the periodic table arranged from group 1 to group 8, or from group 1 to group 18. When you go by group 1 to group 18, aluminum will belong to group 3A of the periodic table. In nature, aluminium is found in the form of its oxide in ore. You can find aluminium as an oxide, not as sulfate, not as chlorate or chloride or nitrate. You can find aluminium in the form of an oxide. And what are the oxides that we can in which aluminum exists? This oxide include: number one, the most important of them is called bauxite. Bauxite, the formula of bauxite is Al2O3.2 H2O. Bauxite is an impure form of alumina, Al2O3.2H2O. Then we have corundum, Al2O3, and we have cryolite, Na3AlF6. These are the major ores of aluminium. These oxides of aluminium are very, very important. The three of them are useful in the extraction of aluminium. When bauxite is purified, you obtain corundum. Cryolite is used as an additive material in the extraction of aluminium in such a way that cryolite is used to perform three major functions. The first function of cryolite is that it helps to make the electrolytic extraction of aluminium possible by uh, by by increasing the electrical conductivity of the electrolyte, increasing the electrical conductivity. To the presence of cryolite ensure that the conductivity of bauxite is enhanced. The major ore is bauxite, but when you add cryolite, the electrical conductivity of light becomes much more visible or enhanced. The second function of cryolite is that it lowers the operating temperature, thereby saving cost, because bauxite is very, very hard. When you add cryolite, it's softer than bauxite because it contains sodium. Sodium is a soft metal, so the presence of sodium in cryolite reduces the melting temperature of the process. Therefore, the operating temperature becomes low, and then you save cost. And the third difference, the third usefulness of cryolite is that it helps to increase the proportion of aluminium that it will be extracted, because it contains aluminium as well. So when you put it there, you will increase the proportion of aluminium in the bauxite. Move forward. Um, move forward. Um, Okay, and we are going forward from here. We move down to all right. In this segment, we want to discuss the diagram of the electrolytic cell for the extraction of aluminium from it ore. Like I said initially, that the ore of for the extraction of aluminium is actually bauxite, but bauxite is also supported with graphite, and I have highlighted the function of graphite, and I won't go into that again. But now, effort will be made to explain the diagram of the electrolytic cell for the extraction of aluminium from it all. From the diagram, we see there are three rods connected to a wire. Three rods. Those three rods are made of carbon, and you can see that those carbon rods are positively charged. You know, this is the positive electrode is the anode. So we have three rods. Sometimes it can be up to five rods, 3 to 5 rods. So those rods or plates are the anodes, and they are positively charged. Anode is the electrode where oxidation reaction occurs. Oxidation is a process where electrons are removed or lost or taken away or withdrawn out of the electrolyte. So the sodium metal loses electron at the carbon electrode. So those three electrodes having positive charges are the places where the sodium metal from the bauxite loses their electron. Then we move on to the body of the diagram. You see the body of diagram that the internal part of it is laid with it has a layer, the internal layer of it. The internal layer of it also contains what I call the lining made of carbon. The lining made of carbon, the cathode electrode. As you all know, electrode are either anode or cathode. So the lining of the internal surface of the cell is where we have the carbon cathode. The cathode is where we have what we call reduction reaction. Reduction reaction occurs at the cathode. A reduction reaction is a reaction in which uh, electrons are gained. So the metal loses electron at the anode, but at the cathode, it is the ion that will gain the lost electron. So the aluminium ion in the electrolyte gains the electron. So the electron gained by the aluminium ion turn aluminium into aluminium metal. In other words, the aluminium ion gain electron and become aluminium metal that we are extracting. So the carbon lining of the external of the structure is very important. Then when we leave the carbon lining, which is the anode, then we now move on to the electrolyte. Then the blue content represent the electrolyte, and the electrolyte is a solution of aluminium oxide and molten cryolite. So it's a mixture. The electrolyte is a mixture of two electrolytes. The first one, or two compounds, the first one is aluminium oxide, it's pure, and the second one is molten cryolite. The two of them combined together form the electrolyte used. Aluminium oxide is very hard and it requires so much temperature to melt. The cryolite is softer than aluminum, so the mixture of the two help us to achieve a very good electrolyte. Yes. Welcome to this class. Um, as we all know, aluminium is a very reactive element, and so it is. It has many uses, and I would like you to know some of the uses that aluminium is known for. Part of those uses, number one, aluminum is used in a wide range of applications in the field of transport and construction. Aluminum is used in building the body of aeroplane because it is very light. An aeroplane is a um, is an aeroplane is an object that flies in air and thus require a lightweight material, and one of the lightest substance that is a metal that is known is aluminium. So aluminium is employed in the construction of an aeroplane because it is light, and so in the construction industry aluminium is important. Aluminium is used also to make some part of the building like the window of building. So aluminum is so important in that region. Second use of aluminum is aluminum foil are used in food industry for wrapping food. This is very important because aluminum oxide is an insoluble compound, and because it is soluble in water, it is saved for the package of food. The body of the of the food can will not in any way scratch because it's highly insoluble. Scientists find it worthy for packaging of food because the food will not be contaminated. The third one is that the dust of this metal is used in paint. In other words, one is used in manufacturing of paint. The fourth one, it is used in the extraction of manganese and chromium from in the oxide. So aluminum is also used for extraction of chromium and manganese. Number five, as it is a soft metal and can be molded into shapes, it is used in the manufacturing of storage can, and those cans are used for packaging foods. After iron, aluminum is the most commonly used metal. It is mostly used with another metal in alloy, meaning that it is blended with another metal to create another compound with a desirable characteristic like stainless steel. So aluminum can be combined with other metal to form a very good alloy. Uh, that has a very strong characteristic that perhaps will resist rusting and corrosion. Number eight, aluminum being light is good conductor of heat and is corrosion resistant and is cheap, is used in making household appliances. Many household appliances contain aluminum or the ore of aluminum. For example, cooking pots are made of aluminum because they are better conductor of electricity because it contains three uh, moles of electron that can per atom, so which means that it has a lot of electron to pass to allow heat and electricity to pass through them. So they are better conductors. And finally, it is used in electric transmission of as it's a good conductor of electricity. In other words, wires, cables of that we see are majorly copper because copper is cheaper than aluminium. Nevertheless, aluminium is a better conductors can be used for making copper cables. This is where I'm going to stop for now. Thank you.